less than 1% of industrial data is being used to make better decisions in companies today. Clearly, if you've made it to this talk, it means that you've read every consulting firm report, every industry analyst tell you how to build more smarter factories and implement AI inside of your operations. There's no shortage of data in this industry. Manufacturing generates most amount of new data annually than any other sector. The next biggest sector is financial services or banking, and manufacturing generates 2.5 times more new data points every year than financial services ever does. So there's no shortage of data, there's only a shortage of insight. Less than 1% of companies are actually using industrial data to make better decisions. But it doesn't have to be this way. But let's try and understand why does that happen. Turns out, the challenge is not so much around the volume of the data or the complexity of the data. It's also not about fears for AI adoption, which is things like workforce resistance or biases in algorithms. Turns out, the answer is way more boring than all of that stuff. And the answer is data governance issues dominate the issue of AI adoption in this industry. 2/3 of executives don't really worry so much about the impact on the workforce. They care more about data, getting access to the right data sets. Is it in the right format? Does it integrate well with the rest of their enterprise data? And can it be securely managed inside of their infrastructure? So it would have been a lot more exciting for me to tell you that it's all the other stuff, but the reality is it's really data governance that's the gap between having industrial data and creating value from it. So at the same time, this data is very complex. It's dense. There's multiple data points per second. There is a lot of incomplete information because there are some sensor measurements that don't get captured at extreme conditions. At the same time, it's not good enough to know that one sensor is doing something on one asset. You have to figure out what multiple sensors are doing at multiple assets and find out the distress conditions only if you look at long periods of time. So non-local features are super important. And the problem spaces are very undefined as well. So you don't know exactly what problem you're trying to solve for when you build out these kind of platforms, but you kind of know that I need this data from these assets for these processes and be able to create value from that. And then the ecosystem for years around industrial data has been closed, full of proprietary formats, impossible to govern, and has had no real collaboration mechanisms, including Catena X. So what could possibly explain these starts and stops in industrial AI? When everybody realizes the value, everybody realizes the potential of what can be done in this industry to really improve the efficiency and carbon intensity of these processes, why is it that AI has not taken off in this industry? It's because of these reasons. It's because of legacy databases. It's because of point-to-point integrations. It's because of black box AI models that nobody can trust. So in this golden era of AI, you have to have a new way to think. Go back to first principles. In order for this to work, what has to be true? And this is where you have a choice. There's a fork in the road today when it comes to AI in this industry. On one hand, you have the general intelligence, which is trained on the works of Michelangelo and William Shakespeare, the entirety of the data on the internet. This is information that is great in the consumer world, but as it's clear to me and everybody else that has even an ounce of critical thinking left in them, that these models are running out of data. The reason for that is the most valuable data on the internet is not found on the internet. It's actually found in companies' enterprise data stores. And that's where it brings me to the second choice. The choice is to build domain-specific data intelligence systems. This is intelligence that's trained on your specific data. So if you are a manufacturer of trains, the design documents of those trains do not exist on the internet. If you're a manufacturing company that specializes in industrial machinery, the manuals of those machines and the service records and the call histories that you've had from customer engineering cases are not existing on the internet. So it's about taking AI and connecting it to your specific data to solve for very domain-specific problems. And no good solutions really exist today. That's what we call data intelligence. So what is data intelligence? A good example of what data intelligence is what we call our product AI/BI Genie. So for many years, you were told that if you just built a dashboard, you would have a lot of insights. The reality is, running your business off of last week's reports or yesterday's reports is no longer scalable nor feasible in a world which changes every day. So what is Genie? It's an agent system. It's an agent system that's prepackaged inside of Databricks, which is the world's leading data and AI platform, that's continuously learning the semantics of your data. So what does that mean? What does the semantics of your data mean? Well, you can call on time in full OTIF. Everybody knows what that means. People talk about overall equipment effectiveness, but those metrics mean very different things to every different company. For example, if you're in the airline industry, you use a term called A15. What does A15 mean? If I go ask ChatGPT what A15 means, it'll tell you it's the next iPhone A15 chip that's in the next iPhone model, because it doesn't know. What A15 actually means is arrival within 15 minutes. And that's why these models need instructions. They need instructions on your interpretation of data to be able to generate high quality responses. How does that become possible inside of Genie? Well, it's using an ensemble of AI agents that's actually continuously learning not just from the data in your platform, but the metadata that's underlying and describing those data sets. It looks at relationships between those different data elements and is able to produce really good responses and extract the right data sets for the right users at the right time. And they're all powered by specialized large language models under the hood. So you don't have to do the fine-tuning work in order to produce the same thing again and again. And we're also moving a step further to help you embed your own unique semantic models. There's no shortcuts. AI is a really powerful tool, but you have to know what to do with it in order to create value with it. And semantic models is an absolutely critical ability for you to be able to bring data models from industry standards, but then customize it to your own unique operations. This is going to be absolutely critical. And the important thing here is it's context aware. So if you ask a question that's not grounded by data sets that are available in the platform, it will ask for clarifications. A great example is we are working with a customer today that's using Genie to give access to field service engineers, access to real data around particular telemetry or case history that they can pull up. Now, if that field engineer asks the question, who is the Prime Minister of France or the President of the United States, that question should not be answered, because that's not what this agent system is built for. It should only be for data retrieval. It should be for specific insights that particular user is trying to get to. So it remembers what it was asked, it seeks clarification what was needed, and it's really, the guardrails are there so that it's only answering from ground truth. And this is available out of the box with the Data Intelligence Platform on Databricks. So what is the Data Intelligence Platform? I just showed you one aspect of that. There's really two very simple things to remember with Databricks. One, you have a unified way of how you manage your data, regardless of what type of data it is. Two, you have a very comprehensive way of looking at how you govern this data in many ways, and this extends also in the space of AI development. So if you got your data management right with an open data lake, which is well organized using unified governance, you can enable AI agents today on the platform. And the beauty of this particular platform, in my opinion, is the fact that it's built on open standards. So no more proprietary formats. You own your own data as a company. And if you don't own your data as a company, I'm sorry, I don't think AI can do anything for you. Because at the end of the day, these AI systems, these AI models run on your data. Without that, none of this works. So what we're able to do as a result of these open standards, the projects that you're seeing on the right-hand side of this slide are the most successful open source projects in data management, in interoperability of data, and even data governance. And not just data governance, governance of AI systems as well, which has been never done in the past. And what that has delivered for customers, and I'll go through a few examples in a few seconds, is the ability for OT users, people who are in the sites, people who are engineers, to collaborate seamlessly with people who are developing the next generation of AI systems. And they're not working in silos. And this is the vision that we are delivering on today, which is you have data and AI assets. So you have data sets and AI models and derivative works in dashboards and reports and predictions that can be used by OT users, but be maintainable by IT users, but more importantly, loved by AI technologists. So we live in a world where industrial data is not just about things that are happening on assets. Industrial asset data is now powering many use cases beyond safety. The roots of this really used to lie in safety, and then it moved to predictive maintenance. But what we are finding in this moment today, in the golden era of AI, is the use cases are way beyond that. There's energy efficiency. There's usage of industrial data for R&D purposes. There's usage of industrial data for better supply chain outcomes. There is a number of use cases that are being powered by industrial data. And if you silo your industrial data and create yet another data store, you're always going to be bottlenecked, and you'll be holding back from all of this innovation. So all of that stuff was important grounding. What does this unlock for me? A lot of times people are like, come in and they talk about, hey, let's do an art of the possible session. And I'm like, hey, if it was already possible, I don't really care, because at the end of the day, it's going to make me more similar to my competition, not help me differentiate from my competition. So our opinion of this is to do things that only uniquely you can do with the data sets that only uniquely you have to think about the art of impossible. So what if we could make predictive maintenance better? What if we could automate product quality decisions? What if we could reduce urban congestion? And what if we could make EVs more reliable? So let's start with that first one, if my slide can move. A great example of Databricks on AWS is the company that some of you heard from earlier in the conference, which is John Deere. Since the inception of Databricks, we've been working with John Deere to really operationalize their predictive maintenance program for all of their fleet around the world. So if you own a John Deere tractor or have operated one or service and support one, all the telemetry data that comes from a connected tractor on John Deere is being used by experts inside of their company to help reduce downtime events and also help them proactively dispatch support. Earlier, it used to take them 4 hours to dispatch somebody after an event actually happened, which caused downtime and caused real business loss to a farmer on the field. Now, they are able to do a risk-based dispatch based on telemetry data, predictive models being shared effectively with their dealer infrastructure, which they don't own. So they have to have the ability to share data outside of their organization, which is powered by Delta sharing. And they're able to dispatch people within the hour of knowing something is going to break. So the downtime event never happens. Another great example is working with the company Corning. This is an award-winning project in deep learning. The challenge, turns out, in deep learning is that you have to have enough data. But sometimes, what really cool thing is, you can have really small data sets, but you can use the small data sets to create larger data sets using synthetic data generation. And that's what the Corning team has done on the Databricks platform. We have a very easy way of using a small data set in product defect detection and create a better, stronger model on day one that's more accurate than human quality control professionals. And this is working side by side with those humans to make the right decisions so that no product that's leaving Corning's 4 walls is actually ending up defective in the customer's hands. So they catch inline defects that are happening on the product factory floor. And we're expanding this not just to their automotive business, but also to their optical fiber business, where the margins for error are even smaller. And what if we could build things that would help reduce urban congestion? One of the biggest challenges in today's world in mobility is the amount of congestion around cities. And autonomous systems operating in closed-loop control areas, especially in logistics, point-to-point connectivity, and even certain control systems in offshore locations like mining are absolutely the required solution. But turns out these autonomous vehicle systems generate a lot of data. They have LiDAR systems, they have multi-sensor fusion, all of those things going on. But you need to train these perception systems on ground truth so that you can do more virtual activity before these systems end up in the real world. So this is something that you can only do if you're able to work on a central repository of all of this multiple sensor data streams and bring them inside of a single data platform that you can then help engineers be more productive in bringing these autonomy features to the market. And this is done all the way thanks to our partners with AWS. Would never have been possible because at the end of the day, these models have to go on the edge and we work with our partners to go deploy them. But what's very, very important is to make sure that you have a central repository and you have good governance on what models get to go on those vehicles. Because without that, you'll always have the risk of safety, which nobody wants. So last one, but not the least, is what if we could make electric vehicles more reliable? No matter which side of the EV debate you are on, one thing is for sure. The battery is the most expensive thing in that vehicle to repair and replace. And then there is tons of reliability issues that happen, and because you don't have enough historical data around failures, you have to be 10 to 100 times faster in getting insight to those things. So what do you need for that? You need the ability to aggregate billions of data points around telemetry. That's exactly what Rivian is doing. You need to be able to come back to the same model that John Deere has done, which is do a risk-based dispatch to help customers save time and actually not have their vehicles be out of service. And you need the ability to be able to optimize and understand how individual products are performing and really do fast root cause analysis to be able to understand why they're failing and what is the root cause that can be traced back to production and supply chain. That's the way you make products more reliable. You can design them, but when they operate in the real world, the story changes completely. And this data and AI infrastructure, the ability to take that feedback loop from products that are operating in the field back into design is going to happen 10 to 100 times faster because every product is a software product that keeps evolving as opposed to the previous way of doing business. So I'll wrap up and say we live in interesting times. This is definitely not my dad or grandfather's manufacturing industry. It was funny, I was doing a FaceTime call with my dad yesterday, and he used to work in General Electric for a number of years. He was so happy to see his son be here at Hannover Messe because he was here many years ago. And it was such a cool conversation to have because he recognized the halls and he looked at this and said, wow, this is so cool that the industry has progressed so much from industrial machines to cloud technology to AI. And it was really a cool moment. And we talked about two things. One, what has changed in the industry? One is every product is now a software product. The changes happening to these products, they live their own lives. And now if you think about a product in the physical world and a product in the SaaS world, the difference between how many times and how quickly they change is actually converging very, very quickly. So you can start to see software-defined features, rollouts that are happening much faster than ever before. So you have to manage those products in that way. And the second thing is there was a blind focus on production efficiency. Turns out production efficiency is important, but what's more important is how you convert those production statistics to actual things that customers care about, which is on-time delivery, which is quality. They don't care what overall equipment effectiveness you run your plants at. They just want their products delivered on time. And that's what matters. And that's the outcomes that we need to start connecting to. And that's not possible with silos system, with fragmented collaboration tools, and definitely not possible with a lack of comprehensive data governance inside of your companies. So I'll just say this. My last message to you is own your data. Because if you do not do that, all of the endless possibilities will never become a reality. But if you do own your data, you are going to make those possibilities a reality much faster than your competition. So thank you very much.